Obviously, story problems aren't always our favorite. 73. But good news is I'm not going to do every single type of story problem that's in this section or in this lesson. There's some a little bit more difficult ones where you're doing like mixture problems and rate, time, and distance of like a car and an airplane and things like that. We're not going to do those as of right now. Thank you. But like I said, it's best if we can look at the problem that we're given. And I'm going to break this up into 2 days. And today is essentially going to be like some of the ones that we've seen where we have like a verbal expression, but it's going to be with an equation. And then we're going to have to solve the equation. Okay? And then on Monday or Tuesday, we will look at some other different types, and it'll just kind of be a continuation. But my goal here is I'm going to do some odds out of the book with you from kind of like the solution set, the exercise set, and then I'm going to assign some evens. So I'm going to try to do ones very similar to the ones that you're going to be assigned today, just so you can kind of see the different types of variations that we might look at. So the first one that we're going to look at here is number 13. Bless you. Okay, now the hard part here is they give us this big long expression in words, and we have to change it into an algebraic expression with an equal sign. Okay? And so it's kind of like what we just did in chapter 1, but now we're taking it a little bit further because we're adding an equal sign to it, and then we're going to solve for a variable. Because a lot of the ones that we saw, like on the test the other day, we're just writing out the expression, 5x minus 2. All right, so number 13. 3 subtracted from 5 times a number is 37. So here's where we just got to kind of think through all of our different operations and keywords that we're looking at. So what do you think I would write first here? Let's say n is my number. We're trying to figure out what the number is. But first of all, we got to write an equation. You can use x if you want to. It really doesn't matter what letter you use, but I'm just going to use n for the number. Okay, and that's going to be our goal, is to find that number. Okay, so what would be the first thing we would write in our expression? 5 times n. Okay. Why do we not start with the 3 first?
Because 3 is being subtracted.
Because 3 is being subtracted from that. Good. Okay. And remember that this is not the same thing. Okay. And so, yes, we're reading it from left to right, but we can't do this because I'm going to get an entirely different answer. We're subtracting 3 from 5 times the number. So you just got to kind of read it carefully. There's my expression. Okay, whenever we see is means equals 37. Now, if I gave you an equation like this, and I said solve it, I think everybody would feel pretty confident with that, hopefully, right? It's just a 2-step equation. Hard part is getting the expression correct first, okay? And that's probably going to be the part that's going to be the most important here, because if I don't write this out correctly right here, it doesn't really matter what I do from this point on. So now we can just add 3. And divide by 5. And that would be our answer. Okay. So not only are we setting up the equation, then we're going to go ahead and solve it. Okay, let's try number 15. Read through it. See if you can write out an expression here, and then we'll talk about it. I'm going to give you an opportunity to try to write it out on your own. Anybody want to give it a shot? Anybody confident that they got this one? This just writing out the equation part? Yeah, let's hear it, Jake.
3 times n plus 4 equals -6.
Okay. Like that?
The parentheses.
Okay, good. The m plus 4 must be in parentheses, okay? Because those are different things, right? Because it says 3 times the sum of a number and 4. So we got to add a number and 4 together, okay? And you can use m, n. I'm going to use different letters here. What letter you use doesn't matter, okay? If you get m equals, like up here, if you said x equals 8 and I said n equals 8, the letter that we use doesn't really matter unless they tell us what letter to use. Or if we're doing a story problem and we're trying to solve for like number of pencils, maybe I'll use a P for pencils or something like that. All right, so that's our equation, okay? And then what do we got to do next? Yeah, just solve it, right? We're going to distribute the 3. We're going to subtract 12. And we get m equals -6. Okay. Everybody good on that one? Questions on that one? Okay. Once again, and I can't stress this enough, getting this equation right here exactly right is the most important part of the entire problem. Because once I do from here, all is based on what my original equation is. So if I don't write the equation correct right here, then it really doesn't matter what I do from there. So you really got to make sure you read it carefully and use all of those things that we did in chapter 1 to kind of help us out as far as like keywords and stuff. Okay, 17. Okay, once again, try to read through this one and see if you can write out the expression. We got a little bit more going on in this one. Each one just continually gets a little bit longer, a little bit more information. What do you guys think? Kind of tricky? A lot of stuff going on there? this one definitely is the hardest of the group so far, right? Because we just have a lot of stuff going on here. And putting everything in the right order is really, really important. So as we break it down, the first part, 8 less than, it's kind of like number 13, where it said 3 subtracted from. That's going to come towards the end because we're subtracting 8 from something. That is not the less than symbol, okay? Because we haven't really talked about inequalities really yet. So other than like using it to compare two numbers, like this one's bigger than this one, we haven't solved inequalities yet. So no less than or greater than symbols right now. The product of 5 and the difference of a number, okay, and 2. The product of 5 and the difference of a number and 2. So once again, x is my number. You can use whatever number or letter variable you want. The difference of a number and 2 and the product of 5, okay? 8 less than that, what are we going to do? Subtract 8, okay, at the end. Okay, is, there's that equals again. Is means equals. That means on the other side, when it says twice the number, we would say 2x, because we're still using the same number. Okay. So it's a little bit different because on this one, when it says is, on the last couple, it just said is 37, or whatever the number was. Here, we actually have an expression on the other side. Now, it's not a big deal because we've talked about solving equations where we have variables on both sides, okay? So that's going to happen. That's what's a little bit different here. So there's a lot of stuff going on in here, okay? And if we don't get it in just the right order, then that's going to throw us off. Now we're going to distribute. Combine like terms. I know we usually say let's try to keep the x positive, but here because negative 18 is over here all by itself, I'm going to go ahead and subtract 5x. Both of these are negative now. So now I'm going to divide by negative 3. I get x equals 6. Okay. No doubt about that's the hardest one so far. Okay. Questions on that one? How confident are you guys on something like that? So? Not so much in some cases, maybe? And it'll just take some practice, right? There's a lot of stuff going on in there, so there's a lot of mistakes that can be made, really easy mistakes that can be made. So just really read it a couple of times if you have to. All right, on number 19. Okay, this one's a little bit different because it is talking about marking things up. If you ever, or maybe you already do, work in a store, then you probably have already heard the terms before, wholesale versus retail, okay? Is anybody in charge of like pricing anything in any job that they do? No? Probably not. Like nowadays, everything's kind of just like you stock shelves maybe. If you work in a grocery store or if you work in a clothing store or something, and now everything's just like one sign for this whole rack or everything's on a shelf. But in college, one of my jobs, I worked at the bookstore in college, and so all the books were priced differently, right? And it was before computers were heavily into like everything was like computer generated and everything. And so we had a little pricing gun. And so like one of my jobs was to figure out how much each book was priced at. So my boss would give me like the invoice and see how much we paid for the book. That's the wholesale price, okay? That is how much the store pays for the book. Okay, so she would buy it from like a company, and she would have to buy a bunch of them, right? Because she had to get books for the entire university for enough people to, and you got books for history classes and math classes and all kind English classes and whatever. So we're talking a lot of books, and then I would have to go and price it. And I got to make sure I price it right, because otherwise she's not making any money, right? And so then you got the retail price, which is what the customer pays. So the bookstore's got to make a little bit of a profit, right? Because they got to pay for shipping and they got to pay for their costs and everything. Just like any store, you got to make a little bit of a profit. And so she's going to buy it for a certain amount, and then she's going to sell it, and then whatever she makes off of that would be off of each book. And so we got to figure out how we're going to do this. Well, in this case, we got a bookstore, kind of like what I'm telling you. They're going to mark up the markup percent is 25%. Okay, and I'm going to show you an easy way you could do this, but I'm going to kind of show you an example of how we would get there. Okay, so back to this one here. Okay, the markup was 25%. We had a book. The retail price is $135.68. That's how much they're selling it for in the store. So here's a little formula that you're going to use. Wholesale times the markup rate. If it was 25%, which it is, we'll just make it 1.25. If it was 30%, I would do 1.30, okay? Whatever the percent is just gets added on, equals the retail price, which is the ending amount. And we know that, right? So this is going to go in right here. 135.68. I don't know the wholesale price, so I'm going to call that X. So we talked about a lot of stuff, but then is this equation very hard to solve now? What would I do to get X by itself? Yeah, just divide. So 135.68 divided by 1.25. Should my number be bigger or smaller than 135.68? Should be smaller, right? Because we're talking wholesale. What did the bookstore pay for that book? What do we get? Anybody got a calculator? Okay. $108.54. Okay. So the worst part of my job when I worked there was at the end of each semester we had what we called buyback. So people would buy their book, in August, and then December would come and their class is over, so they tried to come back and get rid of their books. Well, in some cases, like they're going to go to like a new edition, or they're going to go to a completely new book. And so then we as a bookstore would say, well, we can't give you any money for that book because we're not going to use that book anymore. We can't sell it to students because they're not using it in any of the classes anymore. And it was kind of on the professors, but we're the ones that took the brunt of it. So one year I had a, or in some cases they went to a new edition. So here's what happened one year. I had a student come in, and that's why I was talking about that business law book. The business law book was like $250 brand new. And there wasn't any used ones that we could find for them. So they had to buy this book brand new. And at the end of the semester, they went to a new edition. And then when they came back in, like all we could give them for it was like $20 for the book that they had used for a semester. So they had to decide if they wanted to keep this big, thick business law book they paid $250 for, or get it back for $20, and we would give them $20 for it. And so even though we weren't using it anymore, we could like sell it to like a company, but we couldn't get much for it. And so I always got yelled at the end of the semester because that was my job, you know. And everybody comes in, it's Christmas time, everybody wants money for Christmas presents or whatever, and like, geez, I don't have any money right now. I just want to get, you know, I need gas money to get home for Christmas, or you know. And I was like, I couldn't do anything. It was kind of pretty bad deal, but that was one thing I hated about that job. But I worked there for the whole time I was in college, so I guess I was a glutton for punishment, maybe, I don't know. All right, number 21 is very similar, okay, except this is a discount problem. Okay, a discount problem. If 100% is the price that you pay, and you get in this case, a 30% discount, what percent of the price are you actually paying? 70, right? All we have to do is subtract those two, and we're paying 70% of the original price. We're paying less than what the sticker price is. So instead of adding in and marking it up, now we're marking it down, okay? It's a discount. So here's what we're going to do. We're going to do original price times the percent discount equals the new price that I'm going to pay. In this problem, we know how much we ended up paying. We know how much the discount was. We're trying to figure out what was the original price. Okay, so the hardest part, once again, kind of like we've been talking about all day long, the hardest part is getting it set up. Okay, and in this case, once we have it set up, now is it pretty easy to solve? Okay, now what I should put here though is not 0.30. That's my fault. What should I have put here? 0.70. Okay, 0.70 is the amount that I'm paying, the percentage that I'm paying. 70% of the original price, so that's my fault. So we're going to take $699.95 and we're going to divide it by 0.7. $699.95 divided by 0.7. Okay, what do we get? What did you get, Zach? How much? 99.99? There we go, that sounds bad. Because my number should be bigger, right? 0.93, is that right?
Yeah.
Okay. So that was the original sticker price, almost $1,000, right? And we're only paying $699. So $300 savings. That's a pretty good deal for that computer. All right, that is, I think, all we got for today. Okay. Let's say I have a pair of jeans that the store has a wholesale price of $40. Okay, that's what they paid from the manufacturer, whoever. $40 was their price. Now they're not going to sell it for $40, right? They're going to sell it for more than 40, whatever their markup is. And usually the markup is the same amount on each thing, okay? So if we use the same example here, if I have a 25% markup, how would I figure out what to price these jeans at? What do you guys think? It's not just a flat amount, right? We're not just going to say, $60. I'm going to charge $60, right? Because sometimes you might have jeans that are like $40 wholesale. Maybe you have like a really nice coat that's like $100, right? And so they're all going to be marked up a percentage, not like a straight amount. Same thing with like the bookstore. Sometimes we had like a little novel that was used for an English class that didn't cost much. And then we had like this business law book that was like $250. And it was really expensive. And so you had to price them up the same percentage, no matter what the cost was. So how would I figure out how much the store is going to charge for these jeans? Any ideas? Okay, 25% is 1/4, yeah. So because we have a percent here, what I'm going to do is I'm going to multiply it. Notice I'm changing it to a decimal here. So we're going to take 0.25 times 40. So what is 0.25 times 40? Okay. That would be $10, okay? So is that what the store is going to charge for those? That would make sense, right? They're not going to charge $10. That is the markup amount. They're going to mark it up $10. So what is the store going to charge for those jeans? $50, okay? We would do 40 plus 10, and they're going to charge you $50. So they're making $10 on every pair of jeans that they sell. If the wholesale price was more, then the markup price would be more. So that's kind of the long way to get there. There's a much easier way. If I go back to the $40 here, $100%, if I paid 100% of the price, that would be $40. I'm going to mark it up 25% on top of that, okay? And if I change that to a decimal, that would be 125%, or 1.25 as a decimal. So watch what happens here when I take 40 times 1.25. What do I get? 50, okay? So this is a little bit easier way of figuring out what the retail is. Rather than figuring out what my markup amount's going to be and then adding it in, okay? We can do it all in one math problem, one little multiplication problem. So same page, page 73. Okay, here's what I'm going to tell you. I'm going to assign number 12, but number 12 is a pretty difficult problem, okay? So I'm going to let you give it a shot. We didn't do one like number 12 because I wanted to save a little bit of time. But give it a shot, and then we can talk about number 12 on Tuesday, okay? But give it a try. See if you can get it. It's bad because it's the first problem on your assignment, but the rest of them, we've done problems similar to all of those. So those should be a little bit easier to do. I have a property sheet. Do you want to use that? I know, yeah.